Fantastic. Sreeram, I'm thrilled to have you today. Before, I kind of introduce what is the podcast about, can you maybe please introduce yourself briefly?
Hi, everybody. I'm Sreeram. Thank you so much, Laszlo, for making this happen. I'm Sreeram. I founded a project called EigenLayer. EigenLayer is the mechanism for allowing Ethereum stakers to participate in validating other protocols. Before that, I was an associate professor at the University of Washington, Seattle, where I ran the University of Washington Blockchain Research Lab. So we have been working on consensus protocols, scaling, all these kind of fundamental infra problems in crypto for many years. And one of the bottlenecks we found was, if you have a new idea on what to do with a new consensus protocol, there's very little places for you to experiment and try it out, as opposed to go build your own new layer one. So that's really what EigenLayer was designed to solve. We're really excited to do this podcast with you, Laszlo.
Fantastic. Yeah, and we'll definitely come back to what EigenLayer is about, and also how did you come up with this idea in the first place. And just a quick introduction on Kiln and myself. So Kiln is the leading staking platform, and our mission is to democratize value creation on blockchain. So, which means offering our clients, the users, the most staying rewards, and definitely that's why we here to talk about this fantastic new opportunity and new jungle that is opening through EigenLayer. So, just quick introduction. It's the inaugural episode of our video series focused on AVSs. And we're thrilled to welcome you, Sreeram, as the master of restaking himself as the first guest. And so first of all, thank you so much for joining. And I would like also to encourage our viewers to stay tuned for the next episode featuring Teddy Knox, senior researcher, engineer at EigenDA. And all of our new episodes will be released every Tuesday at 5 p.m. CET. So without further ado, Sreeram, my first question was, I was watching one of the interviews and you mentioned Yuval Noah Harari expressing that the ability for humankind to thrive as a species was to collaborate flexibly in large numbers. Collaborate flexibly in large numbers. Was that one of the reasons you came into crypto? And are there any other reasons?
Yeah, no, that's such an evocative thing for me because, even before I got into crypto, it was something that changed a very fundamental thing that I used to think, which is, if you think about, as an academic, I was involved in innovation, right? Innovation is inventing new things. And I used to take pride in it. And also that basically as a community of innovators, the academics and generally scientists have done a lot. But this thing, when I first read, when it said humans are special, not because we are intelligent, but because we cooperate flexibly in large numbers, kind of struck me as what is this other thing? I thought humans are special because we are intelligent and innovator or inventor or whatever, discover new knowledge. And I think it took me some time to actually understand that. And then you all's logic is that, hey, you take one person away and take one gorilla and one person and then let them fight. It doesn't matter which person you take. You know who's winning that game. But if you took 500 people and put them in an island with 500 gorillas, then humans start to get this emergent dynamic, which is that they collaborate and they figure out, you do this thing, I do that thing, you take care of this, specialize, coordinate, leading to very powerful results. And so that flipped a big thing in my mind, that actually it's not innovation that is driving forward society. The kind of biggest jumps actually happen when you do better coordination. Think of a constitutional democracy. Think of a free market. These are coordinations. Think of property rights, IP rights. These are coordination technologies that just gave a massive boost to everything else that's happening in society. And the way I think, and initially when I came across blockchains, I thought, okay, some speculative technology that I'm not interested in. And also I had like some PTSD from working on peer-to-peer systems 15 years back that went nowhere.
It definitely didn't let nowhere, right? Like,
No, my whole systems went nowhere, but of course, generally peer-to-peer went somewhere. But that was we were building peer-to-peer wireless. I don't think it's a thing anywhere even now. So that basically brought. But once this clicked, that if our ability is to coordinate, then systems that create more rigid ways to coordinate, right? When I'm working with you, I know what I'm getting, what the contract is, how the rewards are going to be redistributed, all of these things. That just makes it so much more easy for any two parties, any millions of parties or billions of people to come together and coordinate. So just like the internet is our information superhighway, crypto is our coordination superhighway. This is the kind of fundamental thesis that EigenLayer is building towards. From the outside, people think EigenLayer is like our public branding is also that. It's the fee-staking collective. But fundamentally in our company, our vision statement is to be the coordination engine for open innovation. That's what we care about. We want open innovation. Innovation and coordination are the only two things that are non-zero-sum games, win-win games. Innovation, you create something out of nothing. Coordination, people come together and do something to enable other people to innovate. So that just, I think, fits what, the UAL's thesis is. And it's just slowly kind of discovered and unraveled that in our journey.
Yeah, it's really fantastic. Like, now you mentioned it, seeing it like as a marketplace of innovation that puts people that collaborate easier to thrive innovation even faster, because that's how innovation happens. That's actually fascinating.
In fact, one of our original model for EigenLayer was, it's a marketplace where stakers, operators, are like selling something to AVSs. And then later, actually, we came up with the model that actually it's not a marketplace, because in a marketplace, if these three parties do the trade, then the trade is complete. But actually, it is the stakers, operators, and AVS creators collaborating, coordinating to offer a service to AVS consumers. So that it's a coordination engine for open innovation, because now as an AVS creator, I don't need to do all these other things. I just need to be innovative, to be inventive, and come up with new and crazy things to do. Then these other parties are already here. The stakers bringing capital, the validators bringing computational resources, as well as maybe the other side of the AVS consumers. If I'm already a consumer of a bunch of EigenLayer services, it's much easier to consume one more service. So this is the coordination engine for more innovation. So that's how we think about it.
Not a marketplace, but a collaboration system for stakers, AVSs, and EigenLayer to bring better services to AVSs users.
Absolutely.
We've mentioned the word AVSs 2 or 3 times since the beginning of this conversation. So what is an AVS? What's your definition of it?
AVS is actively validated service. And what is an actively validated service? This goes back to what I was talking about earlier, why we came up with EigenLayer. EigenLayer is, whenever you want to start a decentralized service, right? Any kind of decentralized protocol, you may be wanting to build a bridge, you may be wanting to build an oracle, you want to build an identity service, you want to build a location service, I want to figure out where the nodes are for accessing something, you want to build an AI service. Think of any service that you want to build. If you the line between building it in the cryptoverse and building it in a cloud universe is decentralized trust. If you have decentralized trust, then you're in crypto land. If you don't have decentralized trust, you are in cloud land. No problem with being in cloud land, but that's the difference. Then, if that's the difference, then how do we make sure that every new protocol has access to decentralized trust? And what was happening was, every new protocol had to create its own decentralized trust community. And that's an insurmountable barrier, Whereas if you were a smart contract on Ethereum, you could just consume decentralized trust. But if you're building a full protocol, which actually requires you to retune how the nodes do various things, what the consensus is, how the nodes access internet or other blockchains or whatever other complex things, you could not just consume decentralized trust. You have to actually create it for your own purpose. And that is such a high barrier. And if you look at the cloud actually also went through the same thing. Like the way you would build a web application back in 1995, right? You have to build your own server, you have to build your own payments, you have to build your own identity, you have to build your own database, and then you have to kind of sell books, right? This is what Amazon was doing. They just want to sell books. They have to build a server, they have to build an identity, they have to build a login, they have to build all the stuff. And in 2024, that's absolutely not how you do it. You go to AWS, you'll get Stripe for payments, you'll get OAuth for identity, you'll get MongoDB for a database. Just build the new thing that you're building, which is, hey, I want to send something to somebody, just use this DB, use that login, use this thing, and then put it together. It's a rate of innovation. That's why web exploded so fast. But that's missing in blockchain today. In blockchains, you have to go produce decentralized trust. So our vision was, if you had a common pool of decentralized trust, now people can build these services, right? In cloud, this was called SaaS, software as a service, right? You write your software, you throw it on AWS, and then every time people are using it, you just have an economic model, which it's earning fee. It is very similar to what an AVS is. It's an actively validated service. You can think of it as a decentralized software as a service. You come up with a protocol or a decentralized service, you write the code, send it to EigenLayer. EigenLayer has stakers, people who stake DETH. Ethereum is the root of all our actions. So because, people are stake DETH, so the stakers are there, the node operators are there, they're bringing a lot of computational resources. The stakers can delegate to one of the existing node operators, or they can delegate to themselves, want to be an operator, totally open. And then once the market is formed, they can now serve any queries that you want to get to the Oracle or the data system or identity system now goes through these nodes. So creating a shared validator set, a shared economic trust. And what that means is now if you have many, many services that are building on top of it, these are called AVSs. We're calling it actively validated services because a lot of people use the word staking, in a DeFi protocol, you say lock up your token for some other token or some other thing, right? But here we have a very specific thing. It's validation. EigenLayer is a universal validation engine. We don't want to do all kind of other stuff and be non-focused. So it's a place to do validation. You want to download and run software and make sure that the output of the software has an integrity associated with it. How do you get integrity? You get integrity because you put a bunch of economic value behind it. And if you are malicious and say something wrong, you may lose your deposit. So that's the system of integrity. That's what an EVS is. Now, anybody who has an idea for how to build, let's say, a new Filecoin, if you go back in history, Filecoin was actually announced in, I think, one of the first Ethereum conferences that, hey, we can build this decentralized storage system. But Ethereum's not programmable enough to go build a decentralized storage system on top, right? You could only build smart contracts, but somebody has to actually do the storage and all the stuff. And that's what EigenLayer is bringing today. If you wanted to build Filecoin today, you could just build it on EigenLayer. If you want to build a data availability system, we are building one. You want to build an ordering system, like a roll-up wants to have a sequencer. All of these kinds of services. Instead of thinking, I think that's another thing that we are working very actively to correct. People think of all these things as chains. I think these are not chains. Chain is just one type of a bundled set of services is a chain. But you can have
these are
as the more native.
Specific services, specific application that still need decentralization because we are in the crypto world. And we keep these services as true as the crypto value, but that have to be chains. That's your point. And that's very interesting. So I see the advantage of not having to run your own chains, asking 60 to 100 to 200 validators to validate your blockchain. And then you still have to find product market fit on your service for your clients. These are two very different things. And I love the cloud analogy of before you had to run your own servers, but then, you could opt into AWS, and we have to replicate that in the decentralized world. I love it. There's two questions emerge. First of all, does it has to be linked to Ethereum shared security? Meaning, like, why, for example, you need staked ETH and not simple ETH, right? To share the security with other services and still have, slashing rules to these ETH being staked to secure other services versus stake ETH. Does it has to be like this?
No, great question. So if you look around, there are many different architectures for shared security. There is, Cosmos had interchain security, called replicated security. They have mesh security. Avalanche has subnets. Polkadot has parachains. Ethereum has rollups. Just a lot going on here. But let me explain why, before we go into particular architectures for should we allow stake deed, should we allow other things, go around like what is the set of like objectives that we're trying to satisfy here. So the first one is there is a strength in sharing security. What is this? Imagine there are 1,000 protocols. Each of them have enough fee to have $1 million stake. Okay. Because if you want to have some stake, you need to have some fee. So let's say you have, each protocol has enough fees to have $1 million stake. They could go around and do that, which is kind of what happens today. Each service has its own stake. And you have like many pools of these stakes. And instead, you imagine you take all the pools together, like all the $1 million, 1,000 pools, and then create a one pool. Now this $1 billion pool, all the stakers validate all the 1,000 applications, 1,000 protocols. Now the same fees, right? So the two systems that we talked about have the total fee for any service is the same, because let's say the shared security has more utility or value or, purpose. And the answer is yes. Why? Because, to attack any one service, I need $1 billion of capital. If I do attack it, I'm going to get slashed for, half of 1 billion or whatever. That's just like a much higher rigidity that I can get by aggregating all of the services into one common pool, as opposed to fragmenting it. Each one has its own little bit of security. Okay, so that's the kind of big picture of why shared security is powerful, is because when you share security, you are getting the effect that to attack anyone, you have to attack the whole. That's number one. But there is something you're losing in shared security. What are you losing in shared security is, imagine one of these 1,000 services is Coinbase. Coinbase is like, hey, I can have 100 million staked, I'd not have 1 million. But if I go into the common pool, I kind of get the same thing as the other guy who could have only 1 million staked, right? So there is no specific, I should get more security, but there's no way to get more, it's just all a common pool. The way we solve it is by creating what we call another dimension of security called attributable security, in addition to shared security. The idea is when you have these 1,000 services and like 1 billion restaked, what could happen is one service, many services may trigger slashing simultaneously. So then you have a conflict of if you burn the ETH, then you're burning the ETH, and like there is no specific attribution. But if you're redistributing it, then there is an attribution, like how much should you give to this one? How much should you give to that one? The way we solve it is we let them bid on how much of attribution they want. So if a service wants more attribution, then let's say Coinbase gets like 100 million attribution. And what it means is it doesn't matter how many other AVSs trigger slashing simultaneously, we will be able to redistribute that 100 million to Coinbase. This is completely no leverage, over collateralized security. That's what EigenLayer is. EigenLayer it's a very interesting mathematical problem to solve, because the protocol has to make sure that how many our services trigger slashing simultaneously, how many our stakers colluded in whatever combination to get slashed in all of these things. The protocol has to ensure that it honors the attribution correctly. It's a very interesting kind of problem, and that one of the core technologies of EigenLayer is actually giving you certificates of attribution. So you get the benefit. So with attribution, what happens is if Coinbase service goes wrong, they get the 100 million and they can redistribute to their customers. But if these other services go wrong, they get only 1 million. But to attack any one service, you still need the 1 billion. So there is pooled security and attributable security simultaneously. And so suddenly you have a market which is uniformly better than the previous market of disaggregated, segregated security. So that's the core kind of technology of EigenLayer.
And just to pause on this, that's one of the way you answer to the question, but I definitely see the value of shared security, but there's systemic risk that wouldn't exist if these services would be completely divided. Whereas they are united, but you mentioned there's attribute security that kind of solves part of the problem.
That's absolutely correct. Because, when securities, so the problem with, if you don't have attributable security is everybody thinks they have 1 billion security, but there is no clear accounting that, hey, I only have a portion of this attribution and you don't know what is happening. It's just like a technical. Instead, by specifically like declaring your preference and bidding on, I need this much attribution and this much pooling, then you have a very precise articulation of what you're getting uniquely. And the other is like best effort in the sense that, yes, if you get... So the attribution is unconditional on other AVSs, like whatever happens, right? That is the really, it provides a buffering for your AVS against all the other AVSs. And as far as you're a staker, the systemic risk is when you're staking into a service and if you don't perform anything malicious, you won't get slashed. That's the staker side. So staker is actually, it's a very different kind of risk. Somebody came up with this example on Twitter. They said it's kind of like you go to a mall, right? You go to a mall and then you have to pay $100, at a store, and you promise that you won't steal at the store. Okay. And that's staking. And then you could say, instead of paying $100 at the store, you pay $100 at the entrance of the mall and say that I promise I won't steal in any of the 5,000 stores here. But it's still in your control not to steal. Like you can just choose not to steal and you'll have your money when you get out. So it's endogenous risk. You control the risk. If you're a validator, if you're a staker, you control the risk. You're not like... Whereas if you basically take a margin lending or like a leverage position by 100x, if the market price of the asset moves by 1%, you will get liquidated. You don't control the market price of the asset. It is something out there, exogenous, the price risk. Validation is this like really amazing and unique thing, which is premised on an information asymmetry. The validator knows that they are honest and therefore they're willing to put their money where their mouth is. But the other guy doesn't know who the heck this is. And they're saying, I don't know you. Oh, but you had this much money. So I know that if you do something wrong, I can take this money from you. So this is what is basically like solving the trust problem by bringing different people with different information asymmetries together. And so that's why EigenLayer restricts its scope to be the universal validation system rather than to be a universal DeFi. And we don't have, you could easily say, like we have money in the world. We could easily say that you can lend against this and the slashing condition is your price went down. This spoils the fundamental structure of EigenLayer, which is purely endogenous risk.
Right. And focusing on the validation engine of attribute security, as you mentioned. So just want to come back on all these AVSs. Started with EigenDA. First of all, can you explain what is EigenDA, why it's important, and why are you launching your own AVS? And I guess a related question is, I'm seeing a lot of AVSs out there. What kind of AVSs are you excited about? Is there anyone in specific? Because we're going to talk to a lot of them in the coming weeks.
Yeah, no, really excited that you're doing the AVS edition here. And, it'll be great to get the audience understand all these different cool technologies that people are building. Starting from the question of, first, why we built EigenDA, and then I'll say, what is EigenDA? Why we built EigenDA? I think there are several reasons we build EigenDA. The first one is EigenLayer is such a complex, multi-sided marketplace. Takers, you have operators, you have AVSs, and to have an AVS commit to building on EigenLayer is a really, really tall order. We've crossed that chasm somehow, but it's not a trivial. You can't assume that, hey, I just create a contract, people are going to put in money and like operators are going to come in, and therefore you now predicate your entire life and protocol on this vault that somebody creates. It's not easy to do that. So what we did is to bootstrap this system, we need to showcase the first powerful AVS that can be built on EigenLayer. So because, if you think about like Amazon, right? Amazon Books, for example, became anybody can come and sell books now, but originally only Amazon was selling books. So you have a complex multi-sided platform. You become one side of the platform, and then like you can get the platform started, and then now other players can also come and participate. So that's the same kind of a thinking. So it's a complex multi-sided thing. How are you going to get all the sides come together? So build one side yourself, so that the stakers and operators are coming because they have at least one service that they can kind of believe in, and that's EigenDA. And then you can ask, okay, yeah, I understand you want to build one service. Why is that service DA as opposed to all the other services? I think there are two kind of main answers. One is I've done a lot of research on DA. That's part of the academic work. Many breakthroughs in data availability came out of our group. So that's one, just like we know this better than most people kind of a reason. The second one is if you look at the roll-up centric roadmap of Ethereum, this is just the biggest bottleneck that we perceive is data availability. Because the total bandwidth of Ethereum, if you just write data to Ethereum, is only 80 kilobytes per second. Now people are talking about this number. I had never heard of this till 1.5 years back, when the first time I just did a very simple calculation. Saw 80 kilobytes per second, and I couldn't believe it. It's like, what is this? It couldn't be just 80 kilobytes for the world computer to build all these layer 2s and everything. And it's true. So that's one reason that we want to actually scale this to much, much higher. And actually the academic and theoretical analysis suggests that you should be able to go to gigabytes per second over if you just optimize engineering architectures. So we just decided that we should start building a high performance data availability system and showcase that, hey, if you have, and Ethereum rollups are branded on Ethereum security. So the closer to Ethereum that you can get and share the security and offer it to a data availability system, that is actually really, really powerful. So that's the second reason. There is a third reason, which is that I mentioned earlier that, we want to have thousands of services, right, building on EigenLayer. And one of the things that this kind of a thing does is every validator has now to download and run thousands of these chains, right? That's a kind of a crazy job. One of the ways we solve it using EigenDA is, for each of those services, if you have to write a data, you can just write the data into EigenDA. And EigenDA itself is a sharded system where no node downloads all the data. Every node downloads a little bit, but together they all download everything. And so that's how we are able to get to 10 megabytes per second, and we have a roadmap to scale it over the next 3 years to gigabytes per second. So that, I think, creates this framework for both bootstrapping EigenLayer, but also offering a core ecosystem service for other AVSs. And another example I'll give you is when AWS started the Amazon Web Services, the first thing they built was a blob store. I can just write a blob and retrieve it. And it's because it's the most basic function of a cloud is you write something and then you read it, right? That's the kind of most low-level native. DA is basically just that with decentralized trust. So it's a decentralized blob store, write it, retrieve it. And so now all the other AVSs can utilize this service, as well as other like rollups exist that can utilize the service. So that's why we built EigenDA. EigenDA has not only this throughput and security alignment with Ethereum, but also has a bunch of new economics which are pretty unique and comes from a first principles understanding of what's going on in blockchains. The first one is reserved bandwidth. The idea of reserved bandwidth is, one of the things we were seeing a lot, and I saw the CryptoKitties craze back in 2017, right? CryptoKitties comes, drowns the Ethereum network, like everybody's trying to download it, and the whole...
I remember very well. End of 2017 is like, who are these little kitties that are actually are breaking down the network? It was kind of running joke, but it actually definitely happened, and for good reason, I think, back if you look back. But yes, of course, that's a very good example.
Yeah, and so the thing is, CryptoKitties now affected Maker, Uniswap, and Compound, and all these other guys, right? And there's no isolation, right? There is no isolation in the sense that, a lot of CryptoKitties traffic affects the CryptoKitties app, but not the other apps. There's no isolation. There's just leakage and negative network effects. Negative network effect is when like the other thing becomes big. No, you don't have enough space. Your gas price goes up, and none of your users won't touch your thing. So capacity limitation creates this kind of like negative network effect or bounded network effect. So you can't go beyond a certain size, because when you try to go beyond that, each app is more negative to the other apps. Normally, each app is more better for the other apps because you can interoperate, you have liquidity, all of these things. But this is the limitation of capacity. Now that if you can stretch the capacity, one of the things you want is containerization, which is I can give you a reservation. Like, you go to Amazon, you buy your own instance, you reserve your own instance, you have it for the entire year. It doesn't matter anybody else does anything. Netflix traffic goes crazy. That instance is just for you. That's the same dynamic.
And you don't have this monolithic architecture, but you scale by containers or clusters. Makes sense.
Scale by clusters is just like saying that, hey, there is this so much bandwidth, and at every moment, this much amount of bandwidth has been reserved just for you, right? We have 10 megabytes per second. So every 100 seconds, we have 1 gigabyte. And out of this 1 gigabyte, you have like 1 megabyte. So like nobody else can write that 1 megabyte other than you. So essentially you have, no contention access to that particular portion of data. And what that means is now, you can actually reserve your data, your price, you have no contention, you have no variability. Because, the price variability is a big mess to building a business, right? Imagine you're building like an airline and you don't know how much jet fuel is going to cost in like 2 weeks. How do you sell a ticket 3 months in advance? You just like taking a guess, right? So airlines usually have contract deals. The biggest airlines will directly have contract deals with the big oil suppliers. Say that I need this many barrels of oil. And that's how you solve it. You just have reservation contracts, which give you reservation. And that's exactly what we do. We give you reserved bandwidth at a constant rate, constant price. And so you don't have to worry about price fluctuation, nothing. That's number one. The second one that we did is that now that you have reserved bandwidth, maybe you don't even have to pay in ETH. That would be the nominal way, permissionless way to use it. But you could come and say, I want to pay in my own token. That's what an L1 does, right? An L1 says, I have like an inflation of 5% that's going to my validators. You could say that's what's going to the DA guy, the EigenDA. So that's number two, pay in your own token.
And on this specific point, would you favor any type of economics, paying in Ethereum or in the native token of the service? Do you have a preference there?
Is permissionless. Pay in ETH is permissionless. Paying your own token for EigenDA needs to be whitelisted by the DAO because, they are reserving a certain amount of bandwidth. They need to pay something valuable. So there is some negotiation. But because it's a reservation, it's for a year. You just do it once and that's every year you have to renew it. But something like that. So as far as EigenLayer, This is all for EigenDA. As far as EigenLayer is much more permissionless. People can come up with all kinds of crazy things of what to do. But EigenDA is like an AVS, so it has its own preference. But it already kind of like absorbs the EigenLayer thinking into its thing. That's why paying your own token is a part of it. The third one, which is even more like taking the EigenLayer approach to EigenDA, is dual staking. So you have a rollup. A rollup has their own token. Okay. Now, many of the rollup tokens don't have any practical utility. What EigenDA does is let you have dual staking, one quorum, which is the standard EigenLayer configuration, ETH staking or whatever. The other quorum is your own token. And whenever the data is dispersed to your system, both the ETH quorum has to sign off on it and your own token quorum has to sign off on it. So that basically means now you are getting additional security from your own like validator community. And maybe many of the people who stake your token will delegate to the same operators that are anyway running EigenDA. Or they may find their own or they may have their own basement operations. You're totally open to all of it. But it's a very simple way for a rollup to add a real, genuine, net positive utility for their token. So dual staking is a native feature of EigenDA. So that's a very insider compatible thing for rollups to come in and say, I get my own bandwidth, I pay in my own token, I have my own token for staking. It looks like an L1. L1, but absorbs the shared security of Ethereum, write data to Ethereum, all of this. So that's really what the economic structure of EigenDA is.
And before, I guess we go, I had like very ecosystem, long-term questions. Do you see maybe one or two AVSs, maybe there's more, that you're really excited about? You're like, wow, the ecosystem needs that. And if it's too complicated to choose one or two kids out of like 15 or 16, maybe thousands tomorrow, like it's fine, you can skip this question.
Specify the categories or meta categories or verticals that we are seeing. I think that's much more interesting. So one vertical is roll-up services, which is, I want to build a DI, I want to build a sequencing, I want to build a bridge, I want to build a watchtower for rollups. All of these, I want to build a finality layer, I want to build an MEV service for rollups. Right? So you have a rollup, I want to build some services for rollups. So that's one kind of big category. And this category is the most proximate, most close, because rollups are already a thing and they need some of these services to actually solve some of the problems. Finality time is large in Ethereum, bandwidth is low in Ethereum, interoperability is expensive and all of that. So you can actually solve all of these things using rollup services. The next category, if you go out of rollup services, is co-processors. Co-processor is, I'm sitting on Ethereum and I want to make a call, but I want to run like some crazy amount of compute. I want to run an AI. I want to run like some complicated ZK. I want to run a Linux machine and get the output. I want to run a SQL server and then bring a guaranteed output. All of these kinds of things. But I'm sitting on Ethereum. It's not a rollup, like rollup has its own state and its own chain and so on. I just want to make a call and get an answer right back on Ethereum. When I get an answer, if this answer comes with some amount of economic integrity, oh, this answer is right, or you can slash and redistribute $10,000. Oh, this answer is right, or you can slash and distribute $100. Now, each answer is endowed with a certain like economic security with it. And, each application can decide whether that's good enough or not. But that's a really interesting new category we're seeing is co-processors. Another category is like complex cryptography, like secure multi-party computation. I want to split my data into many things so no one node has access to my secret. I want to do a complex computation on top of these secrets. You can do that. You can do homomorphic encryption, which is you can directly do computations on encrypted data. You can do trusted execution environments. You can take the Intel SGX, which is a hardware which promises that this particular code ran on this input and then promise the output using hardware security measures. You can run a network of that. So we have projects doing that. This is another like meta category is cryptography. Another meta category we're seeing is proving certain things. I want to prove that I have a certain identity. I want to prove that I bought, let's say, $1,000 worth of goods from Amazon last month by logging into my Amazon thing. And I want to prove it to a decentralized network. I want to prove that I'm logging into the service from South America, not from North America, let's say. You want to prove these kinds of things to a decentralized network. How do you do this? So new people building all kinds of crazy things there. And then finally, so all of these categories I talked about are auxiliary to Ethereum. They're not touching Ethereum main chain in any kind of fundamental way. But because stakers are restaked, they are like Ethereum stakers, you can specifically try to bring new things to Ethereum L1 natively. Like, for example, Justin Drake from Ethereum Foundation came up with this idea of pre-confirmation, which is if you're staked on Ethereum and on EigenLayer, you could issue a thing to a third party saying that when my block proposal comes, I'm going to include your transaction. If I don't include that transaction, then I can get slashed. This is a pre-confirmation I can give to a layer 2 or like some other application that, yes, my transaction is not yet gotten into L1, but when this guy's proposal slot comes, maybe it's the next block, maybe it's in 2 blocks, when this guy's proposal block comes, he will include it, because if it doesn't include it, he's going to get slashed. So these are the kinds of things that we are seeing. I started this thing with coordination engine for open innovation. We're just like totally overwhelmed by the community coming up with all this. These are not our ideas. Like none of these are other than DA, which we are building. This is just the community's creativity that actually is showing up, which I'm really thankful for.
Yes, yeah. Coming back on collaboration and making innovation thrive, and I guess like monitoring these ideas where you wouldn't be even yourself able to think about them. Definitely, you kind of executing the primary vision of it's like innovation through shared and massive collaboration through EigenLayer. That's very exciting.
Yeah, so totally. We're very thankful for the community and want to engage, as people are looking at this podcast, to come up with even more cool and nice ideas. One of the things, we are brainstorming inside our like strategy group, what does like EigenLayer stand for? What are you inventing? Like, that's what we want to stand for. Like, you're inventing something new. You want to be here on EigenLayer with the other inventors who are inventing cool and crazy things.
So if you have a crystal ball and you see the EigenLayer ecosystem and EigenLayer inventors in 5, 10, 15 years, what would you imagine? What would you visualize?
Yeah, I mean, a great thing would be that, Ethereum becomes the center of coordination. And, when we say coordination engine for open innovation, I'm not only really thinking about these kinds of decentralized services, thinking about all kinds of other things that could be built downstream of it, right? Think of how do you, long-range incentive problems in society. So just diving back a bit, you think about, society way back in the tribal times. One of the really powerful things that used to happen is you have 1:1 trust. I know my farmer, I know my teacher, I know my, friend, and we help each other. And if you try to deviate, you'll be like, societal consequences will come back on you. So that's the structure. And what we did is move from that to a very, wide supply chain world where like I had hundreds of teachers. I had like, tens of doctors in my lifetime. I have, I learn and interact with all these people through the core mechanism of economic price, right? So money basically helps me like price out each transaction and just deal with each of them kind of transactionally. I go to the doctor, I pay $1,000 and done with it and move on, right? But what this breaks is this long-term alignment, right? imagine you and your doctor or in your village, and if the doctor is not acting in your best interest and thrive in that village, the doctor is not going to thrive in that village. And so there is this very tight long-term alignment in old school systems that we've lost in this complex supply chains. And the way we could restore it is by using crypto as our coordination layer. And for example, when you go to learn, you have, education, you can give a portion of your future income to actually fund your education. And this will be really, really interesting. It would open up various things. So that's the scale of coordination for innovation that we're envisioning in like a 20-year period. It's just dialing back to what can be built today. And that's what we're focusing on today. But there are all these complex societal problems which are at its heart incentive and coordination problems, right? And to the extent that we can solve it. Another example would be, for example, in AI, there's this big question about how do you incentivize open source AI? That's a big problem because otherwise closed source AI could win. And if you think of it, what is it really? What you're trying to solve is fundamentally, there is a coordination problem, which is I create something, if I just put it in open source, I don't really get anything from it. But other people can build new things on top of it.
It comes back to how do you incentivize open source as a whole, right? Before open source, before crypto and the incentives for the world to build these common goods, it was hard to fund them in many ways, but can crypto solves that for AI and future innovation?
That's something that I'm super, super interested in. What kinds of new models do we need to actually ensure that there are two values here. One is the innovator needs value accrual because, the problem with pure public goods and pure open source is usually open source tilts the thing in favor of the people who already have distribution. If I have already the most distribution, that's why Amazon loves open source. Because, they can just they'll just offer it as a native service on Amazon and you wrote your DB and you're just screwed. And the open source tilts it in favor of people who already have distribution. But the problem with closed source is, of course, that nobody else can permissionlessly improve your thing, and society improves when there is permissionless innovation. Can we break this trade-off between permissionless innovation and value accrual to innovators? And we already see crypto have some way to solve it, but I think we want to dial deep into this, and we've coming up with new kinds of licensing models and all kinds of things where people can permissionlessly build on top of each other. But if you're building on top of somebody, you have to attribute and give value back, a portion of your fee back to the source. So we call this kind of a licensing, permissionless derivatives license. We're working on all these cool things, but fundamentally we're back to the core problem. How do you build the coordination engine for open innovation? That's what we're all about.
I love it. And so if you let me to ask you a last question, very last one, I'm sure you're going to love this one because it seems that one of the primary approach of what became then EigenLayer was, okay, maybe how can we use Bitcoin as, the most, or at the time, the largest security pool in blockchains, and you reuse the security to share it to other services. And last summer in Paris, by the way, you very invited. Next time there's a conference in Paris, we've seen this project and this guy, fantastic founder, David C, and this concept of Bitcoin staking. And I was listening to some of your interviews, I was like, oh, but this is very similar to maybe what Sreeram, had in mind in the very beginning. So what do you think of Bitcoin staking or, Babylon in that case, or any other projects?
Yeah, David Shea is my long-term friend and collaborator. He was also my advisor at Stanford and Berkeley long time back. And we got into crypto on the same day. I remember taking a walk with him in San Francisco and, plotting out what the big problems we need to solve over the next few years are. So I'm really, really glad that David's doing this. And, the first academic paper on Babylon I co-authored with David Shea. How do we think about the difference between Bitcoin staking and ETH staking? Number one, Bitcoin is, of course, a much more bigger market cap asset. That's good. It's even more lindy than Ethereum. That's awesome. But there are problems with Bitcoin. The problem is the Bitcoin blockchain is very, very limited programmability. And what David has done is figured out how to impose one important slashing condition in Bitcoin, which is if you sign a block and sign an alternative block, if you have two headers with the same block number but different block hash or whatever on your service, then you use this complex cryptography called one-time signature to basically make sure that you can get slashed. It's a new invention to do that slashing condition. Amazing. You need a David Shea to do that. But the thing is, Ethereum is fully programmable. So the people don't need to invent new cryptography to invent new slashing conditions. I want to slash you for running an AI program wrongly. I can write a slashing condition on Ethereum. I want to slash you for doing arbitrary things. I can, because Ethereum is Turing complete and Bitcoin is not. So that's one difference. The scope of flexibility and programmability on Ethereum is just orders of magnitude off. But on the other side, what works for something like Babylon is Bitcoin has very little opportunity cost. You can't do anything with BTC. What are you going to do? You can't stake it. You can't do anything else with it. So that works very much in favor of Babylon, which is that, hey, I can actually stake BTC and get something where I got nothing in a trustless manner before. And then finally, Bitcoin is a little bit of a hard community to navigate. They're not pro-open innovation or anything. They see an NFT and they think somebody's vampire attacking their stake.
And I guess that's one of the main reasons you didn't escape Bitcoin because of the hardness of the problem. You escaped Bitcoin because of the community at first, right? Because they were less inclined to innovation.
For sure. That's definitely one important dimension for us because, just going back, dialing back the story here a bit, Vitalik wanted to build Ethereum on Bitcoin. And, the Bitcoin guys hated it. And so Vitalik was forced to build Ethereum as a new blockchain. And when we wanted to build EigenLayer, not only Ethereum didn't hate it, Ethereum's firstly general purpose and programmable that you can actually do it. Ethereum's own roadmap is full of permissionless innovation, like first allowing anybody to build a smart contract application, then allowing anybody to build a layer 2. This is just a natural extension of the Ethereum ethos. So there's those two things. But another thing that works in Babylon's favor is there are not many layer 2s. So Babylon could be the Bitcoin kind of layer 2 tech ecosystem, which is really amazing. So these are different ecosystems, different projects, different markets. But, we are people ask me whether I'm an ETH maxi or what. And my answer is I'm an open innovation maxi. So happy that they're doing that, we're doing this.
Sreeram, thank you so much for your time, for the discussion. I really loved it. It was the first episode of our AVSs series that will, open the coming weeks. And, I was so excited to have you as the first guest. And thank you again for this fantastic project that you're offering to the world, EigenLayer, to thrive collaborative innovation. Thank you, man.
Thank you so much. Really appreciate it. I'm the face of the project and people think I'm doing a lot, but really we have an amazing team. Tina arranged this thing today and we have really, really amazing team which is doing all this stuff. But even more broadly, we have an amazing community of AVS builders. And to the podcast listeners, please do dive into the later episodes and listen to some of the cool new things people are inventing.
Fantastic. And I hope to see you in Paris or,
Absolutely.
other places in the world, but you're definitely invited in Paris anytime. Thanks, man.
Really appreciate it, Laszlo. Thank you so much. Take care.
Bye.